Alright, so we are going to spend quite a bit of time on this section. We're starting it today, but we will be continuing with that next week for sure. We're just going to kind of get an intro today. So we have been doing all this work with polynomials. We now know how to factor polynomials and how to graph polynomials. The next step is how to graph rational functions. Do you know what I mean when I say a rational function? This is on the notes handout I posted on Classroom, this definition, so it's up to you if you want to jot it in your notebook or not. A rational function, rational has the word ratio in it, it's just a fraction. Basically, it's when you divide two polynomials. That makes a rational function. We do have to watch in a rational function, the denominator can't be 0. So when we're talking about the domain of this, we will have to find values, find out what makes the denominator 0. Rational just means you're going to divide polynomials. Domain, when we talk about that, we know the bottom of that fraction can't be 0. In terms of our graph, those are the things that we're going to have to watch, those places where the denominator are 0. That's where our graph is going to do different things. So those will be very key features as we get into the graphs of this. All right. So I want to just start out practicing finding the domain of rational functions. So if it's rational, the denominator can't equal 0. So in this first one, x plus 5 can't equal 0. So x can't be negative 5. How would I write that then? Negative infinity to negative 5 union negative 5 to infinity. That would be my domain. We are going to stick with the interval notation. Unless, I told you before, if there's more than one value that x can't equal, you are allowed to just list them. Otherwise, I expect the interval. Okay. Next one. So I know x squared minus 4 can't be 0. What would you do to solve that? Add our 4 over. And then square root. When you add square root, you need plus and minus. So x cannot equal positive or negative 2. Since it's more than one value, you would be allowed to just leave it. If you chose to write the interval, it would be negative infinity to negative 2, union, negative 2 to 2, union, 2 to infinity. On C, if you set your denominator equal to 0, so x squared is equal to negative 1, what happens when you do the square root on this? You get x can't be positive or negative I. Now, in terms of graphing, does that make a difference? No. So if it's imaginary, then our domain is negative infinity to positive infinity. The only thing that makes it 0 is an imaginary number, so we don't count it. Okay, I want you guys to do the next two. D and E, find your domain. First one, does that denominator ever equal 0? So your domain is negative infinity to positive infinity, because 3 cannot equal 0. E, what can't x be? 1. So our domain is negative infinity to 1, union 1 to infinity. questions on these? I want to mention something. This last function, x squared minus 1, doesn't that factor into x plus 1, x minus 1? These functions are not equivalent. X squared minus 1, even though you could factor it into x plus 1, x minus 1 over x minus 1, if you factored that first, what would happen? Those cancel, and all you're left with is x plus 1, but I'm telling you they're not the same. In terms of simplification, yes, that is how it reduces. But in terms of the graphs, there is a difference. Because the domain of this function is everything except 1. The domain of this function is negative infinity to positive infinity. For functions to be equal, they have to be equivalent and have the same domains. In terms of the graphs of these things, they are going to look different. Now, I will tell you, your calculator is going to be misleading because your calculator reduces before it graphs. So if you type this in, it's actually going to graph this line, x plus 1. But the original one, if you looked at it, since you can't have a 1 in there, what would happen is the actual graph would have what we call a hole in it. It would have an open circle on it. So we will talk more about that later, but I just want you to realize that the domain is very important in terms of our graph. And when we're talking about the domain, you need to do the domain from the original, not after you reduce and cancel things out. All right, any questions so far? The next piece we're looking at are asymptotes. Do you guys know what asymptotes are? You've heard the word before. This stuff is all typed on that handout I posted on Classroom, but you're welcome to write it down if you want it in your notebook. An asymptote is a line that your graph gets closer and closer to without actually intersecting. We are going to look at 3 types of asymptotes in this class. We will talk about horizontal, vertical, and oblique. Sometimes you might hear oblique called a slant asymptote. They mean the same thing. It is possible for a graph to intersect a horizontal or an oblique asymptote at some point, but it will never cross a vertical asymptote. So those are some things to keep in mind when we get ready to graph. So I want to graph a function. We've talked about a lot of parent functions. Let's talk about the reciprocal function real quick. Reciprocal function is 1 over x. So if I wanted to graph this without a graphing calculator, we could make a t-chart, right? That's our strategy that we always use. Okay, if I put in a 1, 1 over 1 is 1. If I put in a 2, I get out half. If I put in a 3, I would get out 1 over 3, so 1/3. What would happen if I put in 1/2? What's 1 divided by 1/2? 2. 1/2 would give me a 2. If I put in 1/3, I would get out 3. Can you plug in 0? Can you do 1 divided by 0? No. Okay, if I put in -1, I would get -1. -2 would give me -1/2. -3 would give me -1/3. -1/2 gives me -2. -1/3 would give me -3. This graph looks like this. Will you do 1 divided by something and get 0 for an answer? No, so it's never actually, we can't plug in 0 and we can't get out 0. So it's not actually intersecting the x or y axis. All right, so there is our graph. the domain of that? Okay, you're hitting everything but 0. What's my range? It's going to be the same thing, isn't it? If you go from the bottom up, you're hitting all these negatives, it stops at 0, and then you hit all the positives. Okay, vertical asymptote. Vertical means up and down. The equation of a vertical line is x equals, what is the number that we can't touch?
0.
So x equals 0 is a vertical asymptote. In terms of graphs, what we typically do for our asymptotes is draw them as dashed lines. So you could draw a dashed line there. The horizontal line we don't touch is right here. What's that equation? Okay, so this graph has both horizontal and vertical asymptotes. All right, any questions there? Let's talk about the reciprocal square function, 1 over x squared. All right, so if we wanted to graph this, we start plugging in some numbers. What can't I put in? Can't plug in 0, but if I put in 1, 1 over 1 is 1. If I put in 2, I get 1/4. If I put in 3, I would get 1/9. If I put in 1/2, 1/2 squared is 1/4. 1 divided by 1/4 would be 4. So this side looks like this. I can't do 1 divided by something and get 0, so it doesn't actually hit the x-axis there. All right, then if I plug in some negatives, if you put in a -1, -1 squared is 1, so I get out +1. If I put in -2, I get a +1/4. -1/2 gives me +4. So my graph looks like this. What's the domain of that one? Domain, if you're going left to right, yeah, we're hitting all the negatives, we stop at 0, and then we hit all the positives. So -infinity to 0, union 0, infinity. Range, what y values do we hit? All right, vertical asymptote. Draw those in. Those are the lines that we're not actually hitting. So it's again just the x and y axis. So vertical asymptote would be x equals 0. Horizontal would be y equals 0. Any questions there? Let's look at a graph and answer some questions. If I wanted to draw in my asymptotes to kind of help me answer these questions, where would my vertical one be? And horizontal would be at. Okay, so what's the domain of this? Range, what y values do we hit? You notice those asymptotes are where we have breaks in our domain and range. The vertical asymptote is where your domain breaks. The range typically breaks at a horizontal asymptote. Intercepts. X-intercept, where does this graph touch the x-axis? 1. If I asked for an ordered pair, it would just be 1, 0. Y-intercept touches the y-axis at 1/2. If I asked for a point, that would be horizontal asymptote. When I ask for the asymptotes, they are lines, so I expect a full equation. What would our horizontal one be? Horizontal is y equals, in this case, 1. Vertical asymptote, vertical is x equals, so it would be x equals 2. Oblique asymptote is sometimes called slant. It's any other line, so any non-vertical or horizontal line. This one doesn't have one, so we don't need to worry about that. For our graphs, we're going to see in a minute, we will have horizontal or oblique asymptotes. We're not going to have both show up on the same graph. Any questions there? So I want to talk about finding these asymptotes from the equations. This is all posted on that handout in class. If you want to write down, let's be very detailed about what we write down. So this is our steps for finding our different types of asymptotes. Vertical asymptotes. So if you're jotting this down, vertical asymptotes are x equals a number. And that number is what makes the denominator 0. So x equals anything that makes the denominator 0. That's a vertical asymptote. Horizontal asymptotes have very detailed rules, and you need to learn these rules. It's all based on the degree. So if you don't want to write down in terms of this, if that's confusing to you, basically if the degree of the top is smaller, you have a horizontal asymptote, I call it HA, y equals 0. If you have the same degree on top and bottom, you need to divide the leading coefficients. And if the degree on top is larger, there is no horizontal asymptote. So, 3 cases. If the degree of the top is smaller, it's always 0. If it's the same degree on top and bottom, divide leading coefficients. And if the degree on top is bigger, then you don't have a horizontal asymptote. And then I'll move on to the horizontal once we have the vertical down. So vertical, we are just looking at the denominator. What makes it 0? So let's try. So in order to find out what makes this 0, what are you going to have to do? Okay, we need to solve for x. So x squared equals 4, so x is plus or minus 2. For our domain, we said x can't equal those things. For the vertical asymptote, those are your vertical lines. You can leave it like this. If you want, you can separate it. I call vertical asymptote, I say VA. So this one has 2. X equals -2, x equals positive 2. Those are the 2 vertical lines that our graph doesn't touch. B, what would be our vertical asymptote? 1. X equals 1. I do expect equations for these because they are lines, so you need to have the x equals when you write them. C. Does x squared plus 1 ever equal 0? We did this one earlier with domain, didn't we? Does x, if you solve this, you get an imaginary. So we don't have to graph that. So in terms of our vertical asymptote, there isn't one. If the denominator isn't 0, you don't get a vertical asymptote. And last one, what should I do? Factor approximately. Multiply -21 and add to +4. So my vertical asymptotes would be x equals 3 and x equals -7. So it is possible to have multiple vertical asymptotes in a graph. So far, so good? Let's talk about horizontal asymptotes then. Horizontal asymptotes are based purely on degree. You don't have to factor anything or do anything fancy. We need to look, what is the degree of the top? And what's the degree of the bottom? Okay, the rule is, if the top has a smaller degree, then what's our horizontal asymptote? Y equals 0. It's based off, ironically you came in saying you didn't know how to do long division today. It's based off long division. If you were to divide these, can you do x divided by 4x squared and get a whole number? No, so that's why it's 0. It doesn't divide evenly. Okay, you know what, I think, okay, I'm going to jump around a bit. I'm not going to talk about oblique today, so we're kind of running short on time. I just want to do a couple more practice with horizontal, and then I'll hit oblique on Monday. So this one. What's the degree of the top? What's the degree of the bottom? Okay, if it is the same degree, I told you that you divide the leading coefficient. So the leading coefficient on top is 8 and the bottom is 4. So 8 divided by 4, so y equals 2 is our horizontal asymptote. I want to put, I don't want to do that one yet. Okay, let's do this one. What's the degree of the top? Bottom? So same degree means divide leading coefficients. This is a 3. What's the leading coefficient down here? So my horizontal asymptote would be Are we okay with these? Alright. I am going to stop here for today. So your homework, page 372, we're going to do 9 through 16. Going to modify this just a touch. And then we will hit the oblique asymptote.